In the previous installment, we looked at the small angle approximation, and we said that for small angles theta equals sine theta. We wanted to determine how small is small and how large theta could be before it's no longer true. So we investigated it for sine, and what we found, to one significant digit, it's true up to an angle of 38 degrees. But in science, we don't have measurements that are one digit. We have a minimum of two, a certain digit and an estimated or uncertain digit. So to two significant digits, it's good up to 17 degrees, which is pretty large. Very often, if you look online or you read in a textbook, it'll say up to 20 degrees. Well, not quite 20, but 17 degrees. And by the time we get to very small angles, like 3 degrees and 1 degree, we have 4 significant digits of agreement in the decimal place. So it's really, really quite striking and powerful approximation. Well, then we ask the question, well, what about cosine? Is it true for cosine, or is it true for tangent? And let's find out. So how we will begin to keep this much simpler for ourselves is we already have a spreadsheet made for sine, and everything is going to be the same for cosine except the cosine. So we'll duplicate this sheet and we'll name it cosine. And we'll change this to cosine. And cosine of B2 should be 1, at least in degrees. That's 1. And we'll fill this down. To 90 degrees. And messy numbers, let's take it to one significant digit. So let's see where the difference is 0. Definitely not at large angles. It goes down to 1 at 0. Ooh. From 58, it becomes 0. All the way to 24. Huh, curious, it's a central band. And then the difference gets larger again. So we don't have any agreement here. So the idea that the cosine of theta might equal theta is, for small angles, is out. For small angles, it's definitely not true. We might expand the question or modify the question to ask, is it valid for any angles? And to one significant digit, it does seem to be the case for 24 to 58. But as we know, that's not a scientific measurement. So it's not really going to be helpful to us at that level. So let's take it out to one actual significant digit. And we can see here, oh, what was 0 is now becoming not 0. But we now have this new zone, 41 to 44 degrees, which is, indeed, it seems, to one significant digit. Well, of course, one significant digit isn't a number, the right number of significant digits for a scientific measurement. So let's take it now to 3 significant digits, or 2 significant digits, excuse me. And if we look here in the zone, there is none. We might imagine that this number has to flip from here and here. It has to flip from 0.01 to 0.02, but at most we're talking about maybe one particular degree. So in the end, what we can say is that there really isn't any practical use for approximation of theta equals cosine theta for small angles or really any others. And so we will just say none. It's not valid. Valid at any angles. So of course, it looks like then maybe this won't be anything even for tangent as well, but we want to do our due diligence to see, lest we quit too soon before we make a breakthrough. So now let's take our sine, which was our original. We'll duplicate again. And this will be our tangent. And again, at the top, we're going to change that to tangent and the function to tangent. And 0 is 0. And now we'll fill that down to 90. So we don't get cross-eyed looking at the numbers here. We'll bring these down to a whole number. And what we can see here is that to a whole number, it does become 0 at 55. But again, that's not even one significant digit. That's to a whole number. Now, if we format those numbers down to one significant digit as opposed to one whole number, we get to 0 at 29. Now, we encountered this at 38 for sine, so smaller angle it looks like. That's one significant digit. So we're almost to the realm that we could use this in science. Let me get rid of the markers from before. And now the moment we're waiting for, is it work at 2 significant digits? And the answer is yes. We get it at 2 significant digits, 14 degrees. Now this is kind of surprising because if we remember before, we had 38 for sine, 29 for tangent, 17 for sine, 14 for tangent. So it actually looks like they might be even converging. Let's go now to 3 significant digits. And lo and behold, we have it at 6. And it was 8 for sine. So they are seemingly getting closer together. Let's go to 4. Four significant digits comes into play at 3 degrees. And of course, we wonder then, will it occur with 5 significant digits? Or should we say the 100,000th place? And we can see that we have agreement to the 100,000th place at 1 degree. At 1 degree. So this is to the 100,000th place. Here we have just agreement to the 10,000th place. Here we have agreement to the 1,000th place. Here we have it to the 100th place. And first comes into play the 10th place. 29. So we have 29, 14, 6, 3, 1. So bringing it back home, we find overall that we have 1. Oh, we'll start up here with 29, 14, 6, 3, and 1. So this is pretty shocking that the small angle approximation is not only for small angles of theta, does theta equal sine theta, but for small angles theta, theta equals tan theta. Which is a wonderfully surprising result and a fabulous tool for us to use, should we need it. In our next installment, we're going to continue our discussion about simple harmonic motion and determine whether particular phenomena do obey simple harmonic motion.